Hello, everyone. Greetings of the day. Dear authors and invited guests, welcome to Technical Session 4A. Myself, Prashi, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GIA Scholastics, it is my great pleasure to welcome you to the 10th World Conference on Information Communication Systems, Software, Security and Sustainability, WorldS4 2026, London, UK. The 10th edition of this conference is being organized in a hybrid mode. The physical event was held yesterday in London, UK, and the virtual event is being held through Zoom from 29th to 30th July 2026. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentations and 3 minutes for the question and answers. On the 10th minute, I will be raising a gentle reminder. I repeat, on the 10th minute, I will be raising a gentle reminder. There is another request to all our participants that you all stay connected with us till the closing remarks. If you have any queries or any updates, then you can write it to me in the chat box given down below. Just before we start our session, I would like to introduce you all to our session chairs for this session. Dr. Sachin R. Jain. Dr. Sachin R. Jain is an associate professor at Oklahoma State University, United States, with over 23 years of teaching and research experience in computer science and engineering. He has published more than 30 research papers in international journals and conferences. His research interests include wireless sensor networks, artificial intelligence, Internet of Things, blockchain technology, machine learning, pattern recognition, and digital image processing. We welcome you to the session, sir. Would you like to give any heads up to our participants before we start our session today?
Yeah, thank you, Prachi. Am I audible to you?
Yes, sir.
Yeah. Um, Dear participants and guests, it's my great pleasure to privilege to welcome you to this technical session of 10th World Conference on Information Communication System Software Security and Sustainability. As the session chair, I am delighted to welcome such a diverse, talented, and accomplished group of participants representing expertise from around the world. Over the next 30 minutes, we'll explore a range of exciting research topics united by the common goal of advanced knowledge, innovation, and collaboration. I encourage everyone to make the most of this opportunity by engaging actively in the presentations, asking thoughtful questions, and contributing to meaningful discussions. With that, I wish you all our presenters the very best, and I hope you find the session insightful, engaging, and inspiring. Thank you.
Thank you so much, sir, for your enriched and enlightened words. Now, I would like to introduce you all to our second chair for this session. Our second chair is Dr. Ruchi Nanda. Dr. Ruchi Nanda is an associate professor and head in the Department of Computer Science and IT at IIS, deemed to be University, Jaipur, with 17 years of experience in teaching and research. Her area interests include big data, cloud computing, machine learning, and databases. Ma'am, we welcome you to the session. Before we start, would you like to say anything before our presenters and guests today?
Thank you, Prachi. Thank you, GR team, basically, for inviting me in World 2026 10th International Conference, and I am honored to be here. And I wish all the participants all the best for your presentations, and that's it. And please stick to the timings.
Thank you so much, ma'am. As ma'am has reminded, I request you all to please be aware of the timings.
Yeah.
Now,
Thank you.
thank you so much for your opening remarks, ma'am. I would like to introduce you all to the first presenter of our session. Our first presenter is Nergiza Rubevza, presenting a paper on the title "Developing a Digital Financial Ecosystem Model to Support Innovation in Tourism Enterprises." I request you to please kindly take over with your presentation.
Good morning, everyone.
Good morning.
I am trying to share my screen. Just a minute, please.
Yes, ma'am.
But I'm not able to find it.
Could you see the
From-
share screen in the...
Yes, I'm seeing that.
Okay.
Yeah, now I can.
Okay, ma'am.
Is it visible for you?
Yes, ma'am, it is visible.
Okay. Sorry for inconveniences.
Ma'am, before you
Hello,
start,
everyone.
could you please press F5 for the presentation mode so it will be more visible to us.
Just a minute.
Yes.
Yes,
Thank you.
that's it, right?
Yes, ma'am.
Thank you too. Our topic is developing a digital financial ecosystem model to support innovation in tourism enterprises. And I am one of the co-authors of this scientific work. Our research overview is that tourism enterprises rely on continuous innovation to maintain sustainable growth. That's why we chose this topic. But traditional financing models are often too rigid and inaccessible for small and medium enterprises because they don't have such a big infrastructure and opportunities. But high information asymmetry and collateral requirements restrict innovation capabilities for small businesses in tourism industry. This is our research context, and we used some models for our research methodology, and we propose that a unified digital financial ecosystem combining fintech, credit scoring, and smart contracts. Our research employs a dual approach: dynamics modeling, and simulation for our data analysis, and our results show significant reductions in transaction costs and increased funding accessibility if our proposed ecosystem is used. And our research identifies digital maturity as a critical mediator driving long-term innovation performances. The challenge for this sphere is that tourism market volatility requires constant product and process innovation, but small and medium enterprises face severe capital bottlenecks, and traditional banks view tourism projects as high-risk investments. Our research gap is that fintech adoption remains fragmented across regional tourism sectors, and lack of integrated credit scoring models tailored to service data, and limited ecosystem frameworks connecting investors and enterprises. Our objective was to develop a holistic digital financial ecosystem model to evaluate dynamic feedback loops between finance and innovation and provide empirical guidelines for policymakers and managers. So, digital finance and fintech platforms, what do? They peer-to-peer lend and crowd invest, democratize enterprises funding access, and it lowers market barrier for non-traditional service innovation projects. Data-driven credit assessment, it's one of the foundations of our ecosystem, and big data analytics replaces collateral-heavy banking checks, and real-time cash flow and booking analytics improve credit scoring precision. And smart contract mechanisms and is another aspect of our ecosystem, and our ecosystem synergy is that it integrates infrastructure, regulation, and enterprise digital capabilities, and it shifts focus from isolated financing tools to network level resilience. Our methodology approach was that we used both quantitative empirical approach, and we simulated our results to check them. So our target audience was that we surveyed management personnel across regional tourism enterprises, and they were more than 800. And our tool was for our empirical approach was that partial least square structural equation modeling, and our purpose was this purpose of this model was it validates hypothesized direct and indirect structural paths. And when it comes to our simulation, for our tool was for simulation system dynamics, stock and flow modeling, and it focuses on non-linear time-lagged feedback responses. And key variables for our simulation were capital inflows, technology adaptation rates, and transaction costs. The purpose of simulation, it evaluates long-term policy scenarios over multi-year horizons. Our ecosystems conceptual architecture, it's financial inputs, core ecosystem, mediators, and innovation outputs. Our financial inputs were open banking APIs, fintech platforms, alternative crowdfunding, and micro investments. And core ecosystem is smart contracts, big data credit scoring, automated risk analysis, and real-time auditing. Mediators are enterprise digital readiness, staff digital skills, data transparency, and process integration. And our innovation outputs are service product upgrades, reduced transaction costs, enhanced market research, and sustainable growth. So this is our result of our model. It can be seen that access creates innovation, and it says that direct access to capital accelerates product update cycles. And the next one is smart contracts reduces cost. It means that automation significantly lowers operation friction and overhead. And our mediating effect was that high internal digital readiness multiplies the benefits of financial access. And this one is our simulation results. And there is a loop in simulation, and it's like that. Higher fintech accessibility creates increased innovation investment, and it creates greater enterprise revenue, and in turn, this creates higher credit trust score. We simulated some policy scenarios, and baseline scenario was traditional financing yield linear, low tempo innovation growth, high digital integration was integrated ecosystem accelerates innovation adoption by over 40% in multi-year simulation, and cost resilience, lower transaction cost buffer enterprises against seasonal demand fluctuations. And our conclusion is that enterprise readiness. If enterprises are ready, internal digital transformation is necessary to unlock fintech benefits. And tourism, small and medium sized enterprises should diversify away from strict traditional banking toward P2P and crowdfunding because it's more easier and efficient. And they should implement smart contracts to streamline vendor and booking settlements, and it reduces time and money funding. So our policy and theoretical contributions based on our research. We suggest regulatory sandboxes. Governments should establish safe regulatory zones for regional tourism fintechs, so that policy implementation could be easier, and builds centralized big data scoring platforms for service sectors, small and medium-sized enterprises, especially in tourism, because it makes it makes innovation easier, and our policy expands tourism economics by demonstrating the structural interplay of digital finance and enterprise resilience. But we should state that our results are highly concentrated on only tourism sector, and it concentrates tourism enterprises, and especially small and medium ones. That's it. Thank you for listening.
Thank you so much, ma'am. I would like to ask our session chairs, do we have any questions?
Hello, thank you for your
Hello.
presentation.
Thank you.
Have you just done the simulation or you have implemented it somewhere in the real-time scenario?
No. We simulated in Simulate program. It was digital.
It was digital.
Yes.
Okay, so which component of your digital financial ecosystem had the greatest impact on the innovation financing? Did you get the question?
Could you repeat it, please?
Which component of your digital financial ecosystem had the greatest impact on the innovation financing?
If we concluded that if ecosystem is bigger and tourism enterprises have more information, it creates financial accessibility more. I mean, digital financial infrastructure of the enterprise affects more.
Okay. What do you consider the biggest challenge in implementing this in the real world?
The challenge is that digital readiness is not that much big in tourism companies because they are not so much literate, IT literate, and also there is also labor problem with digital literacy is quite lower in this sphere.
Okay, one more question. Can your proposed model be generalized to the tourism enterprises in different countries and economic contexts?
You mean our research results?
Yeah, can be like whatever your model you propose, can it be generalized to any other like countries and ecosystem like
No, it is
no.
for emerging economies, not
Okay,
for
thank you.
all. Thank you for
Thank
your
you.
question, sir. Thank you, Professor.
Dr. Nanda, ma'am, do we have any questions from your end?
I just have one query. You have mentioned 40% is increase in innovation adoption. I think it's slide number 8. You have mentioned it. Can you come to slide number 8? And it was on 8. So how will you justify that?
I'm so sorry, ma'am. I cannot hear you that well.
Ma'am, she's
Slide number
asking you to take slide number 8, please.
8.
Ms. Nargiza?
Am I audible?
No,
Can you come to
ma'am,
the
I
slide
cannot
number
hear
8?
you.
Can you come to slide number 8?
Slide? Okay.
Slide 8. Yes.
Can you
mentioned here,
please see it?
integrated ecosystem accelerate innovation adoption by over 40%. So how this you validated this statement by over 40% in multi-year simulations? Is there any approach you have used to validate it?
Hello.
Hello?
I'm getting slide number 8 page, but I cannot get your question because your voice is really low for me. Can you
Okay, then.
can you write your question in inbox, please?
No, you have mentioned 40% in your slide.
Okay.
Am I audible
Yes,
now?
40%. Yes.
40%.
Yes.
So how you have
Mhm.
validated this?
You mean 40%?
Yes,
Based on
yes,
our
yes,
simulation, based
yes.
of our simulation model, we run simulation model on simulate program, and based on the results, we can say that it increases 40%.
Okay, okay, that's it. Thank you, and
Thank you.
for a very nice presentation. It was very comprehensive. All the best.
Thank you, Professor.
Thank you so much, ma'am, for your presentation.
Thank you too.
Now I would like to call upon our next presenter. Our next presenter is Heidi Kovisto, presenting a paper on the title Generation of AI-Assisted Robot Framework Test Cases, a comparative study of AI tools in software quality assurance. I request you to kindly take over with your presentation, please.
Yes, thank you. I will share my screen.
Yes, ma'am.
I have not used Zoom before this, so it's requesting some accesses in Mac, so takes a while. Let's see. Can you see it now?
Just give me 1 second.
Not yet, not yet.
Not yet. Now I can see it.
Good.
Yes.
So
Okay.
can you still see it?
No, ma'am, now we cannot. It was there just a second ago.
See again. There again. I have not been using Zoom before this.
Okay. I request, okay.
Yes, let's try again.
Now it is there. Now it is there.
And is it still there?
Yes, now it is still there.
Yes, good.
Mm.
Nice. So thank you. So my name is Heidi Koivisto, and I will be presenting our paper on generating AI-assisted robot framework test cases. And this is a comparative study of AI tools in software quality assurance. And our team is not just me. There is Sari Ahonen, Katja Saarla, and Henri Terho with me doing this research. And we are doing this in industry. So me, myself, I am a PhD student, and there is another PhD thesis coming from out of this, several master theses, and we are doing this at Efficode. Efficode is a DevOps company, and we are concentrating on software development life cycle and doing that with AI. And all the team members in this research group, we have like every one of us have 20 plus years experiences in all phases of this life cycle. So I am myself mainly as a developer, and Sari is a quality assurance consultant, and there's also some university backgrounds in our group. And this is a program from Business Finland, and the program is Manage AI-powered software innovations. And our research goal is to provide an analysis for several popular AI tools and in the context of test case generation. And we aim at creating a model that could be used in several production level projects, where some of the projects may have unit tests already, some may have integration tests, some may have end-to-end tests, some may have nothing at all, or if there is some tests, those may not be kept up to date. So in this is the first, this is the beginning of the research. So we are just creating the model, how that could be used in different scenarios, and then we go into the different companies to try this out in the real world production software. And we also want to evaluate how these AI tools perform in these real world cases and whether the using AI can really enhance the quality assurance process and without introducing new issues. So that is not just moving the effort from one place to another one. And we are talking about efficiency, productivity, and then sustainability. Is it like worth using so much energy to do it with AI? Is it worth it? And is the quality of the results good enough or even better? So we are thinking also when doing this research, the economic perspective and the environmental perspective, that is it worth using the large language models to such tasks, and also the social dimension, so that when there is a new junior level developers, how they can get into this old legacy systems with help of AI. So we are also studying how people learn. And the AI tools we used in this research are GitHub Copilot, Amazon Q, GitLab Duo, and Cloud Code. And we use the same prompts to all of these tools, same evaluation criteria. We generated test cases using robot framework, and that was the same task for all of these. And something about software testing. So as I already mentioned, there's this unit test, integration test, and end-to-end test. This create this kind of test automation pyramid. And this study focuses on the upper layer, so UI and API integration tests, which are typically more complex to generate and maintain than the unit tests. And of course, then it's also more difficult for the AI. And with the robot framework tests, it's the behavior development comes into the table when we need the test to use the exact format that it's not good enough to have a working test. It needs to be following all the rules that are in there. And this is an example what a robot framework test case looks like. It's like simple English. And this is not a working test case, just an example that there is a test case that contains these keywords, and there needs to be this Kerkin format given when then. And there is some given case, and then something happens, and what needs to happen after that. So as this is just English and it's using large language models, you may assume that it's very simple task when you guide it with English and it needs to produce some English. But in this robot framework case, it needs to understand the whole software, how it goes, where it goes next, and what happens when you press this button. So it may look simple, but under the hood it's not, even with this very simple example application. And we had a example application for this. This is not anything, this is not in production. This is just for testing the model we are creating here. So this is application that is using Python. There is some APIs, database, and then there is a UI. And from the UI, you can create, read, update, and delete books in a library. And then we create this model that has these phases. We first give the context to all these tools, so they have the same starting points, so they know the environment where to find. There's ready-made scripts. All the AI tools can use the same scripts, so they are on the same line. Then in the model we create the tests, and then in the self-healing phase we run the tests, and if the tests are not 100% passing, then we do it again and again. And this is the same for all these tools. Of course, some of these tools, they have built-in agentic workflow already, and they are doing this inside the tool already. But we make sure with this our model that all the tools can do the self-healing. If the tests are not passing, then do it again. And when the tests are passing, then we still check that the results are good, so that the Gherkin format is in use, and it's like maintainability is the main issue in here. And here are the values we evaluate when we check the results. There is human in the loop, so we check the test quality and the structure, the maintainability and the modularity, correctness, coverage, execution quality, project guidelines, static code quality. We run Robocop to test these, and the test architecture is good, and the test suite volume is good, and the prompt responsiveness is good, and the usability. And these are defined based on several loops with several experienced test engineers, and these weights that these categories have been modified several times, so that there is an agreement with the test engineers that this is like following the best practices of software quality assurance. And there is in the paper a lot of tables about the results divided like from the previous table into categories, values for all of those. But here's the main results. So GitHub Copilot performed the best, and then there's coming GitLab Duo, Cloud Code, and Amazon Q with the previous tables evaluations. And then about the leader spotlight, GitHub Copilot was the best. Of course, all of these, they have their limitations. GitHub Copilot is Microsoft product, GitLab Duo is GitLab's product, and so on. So GitHub works best in the Visual Studio Code and so on. So GitHub Copilot made also the broadest coverage of the tests, but GitLab Duo made more test cases, and both also had their own limitations about, for example, GitHub Copilot used a lot of words that nowadays are not used and should not be used. And then there's these two others, Cloud Code and Amazon Go. They are having strong built-in agentic loop inside of them already. And I would assume, because they are already agentic loops inside of them, that they would perform much better. But at least in this case, they of course, this is a good result anyway, but Copilot and GitLab Duo made it better.
I'm sorry to interrupt, ma'am. However, we have crossed our 10-minute mark. I request you to kindly wind up as soon as possible. Thank you.
Yeah, so for the key findings, the pipelines, we have more speed to create the tests, but we need still the human monitoring to see if the results are good enough. Because without the human, the results were that it's using legacy syntax, for example, that it's not maintainable, and that is really important when we are going into production. and having the readability of the test and robust formatting structure, and not using the old legacy syntax. And moving forward, we are next going with these models into the real world examples. This was just a Python application, and that's it. And that's all. Thank you.
Thank you so much. And I would like to ask our session chairs for any questions.
Thank you, Heidi. Can you hear me?
Yes, I can.
Yeah, I have few questions. Um, how many trials did you run per tool? And did you pin the versions, different versions of those tools, or just like you haven't do it?
The versions of the tools and also the large language models that are used in the tests mentioned the versions in the paper. And before we did the official runs, we had several runs for each of these tools. First separately because there's differences between the tools, and then when the tools were compared separately, then put those together. There was 4 engineers doing it separately with each tools, and then they combined the benefits of each tool, and to create a model that fits all of them, and creating the first level so that everyone has the same and everyone benefits from that. So
How
running
did you
first,
standardize? Sorry.
yeah,
How did you standardize the prompts across such different tools?
Because, well, of course, when using large language models, it's not never deterministic. So every time you run it, you may get different answer. So before doing these official runs, they have run it hundreds of times, trying different prompts. And first separately, then with the same prompt to all of these tools.
And how did you validate the correctness of the AI generated test cases beyond the code coverage matrices you mentioned in your slides?
Yeah, there was this table that had the weights for different categories. There was several humans reading those test cases, and also all the results were also run with these different tools. For example, Robocop, that is used for evaluating the style of the robot tests.
So
And
have you used any the humans were some expertise or something like
yeah,
that?
and all the humans that were in this evaluation phase, they were every one of them have 20 plus years of testing experience. And also Cloud Code made evaluation for all the results.
Were there any types of test cases or scenarios that the AI tool consistently failed to generate? Have you encountered such test cases or scenarios?
There were, and they in interface when they created the prompt before we had the final prompt, there was a lot of, and the main issues were with the Cloud Code. All the others were passing, but Cloud Code didn't. And of course, it
Okay.
created the test case, but the test runs were not passing, and they had to iterate the prompt quite many times. And still now, when
Okay.
we are continuing the research and put it into production, there's still need to iterate the prompt.
So
Even
you
though,
haven't tested it on large scale and real world software projects yet?
those are now going on
Okay. Thank you.
for different companies. Yes, thank you.
How many test cases were generated as you were
25.
talking about? How many test cases you generated for each tool, basically?
GitLab Duo created the most. It created 25 test cases.
Okay.
But
And
still,
why? And you have not included Chat GPT or Gemini. Is there any specific reason that you have included GitHub, uh, Copilot, but not Chat GPT or Gemini?
those tools are not that commonly used within developers. because those are not that easy to use. Because with these tools that we selected, it's easy to integrate those into the tools developers use daily. So for example, I use as a full stack developer Visual Studio Code, and I have integrations to the Visual Studio Code with these tools. And also the command line versions can be used, but there isn't just such things for the other tools. There's if we used ChatGPT, we would need to use the API, call the API from the model, and so on. So it's much easier with these tools, and these are most commonly used within developers.
Right. Okay. Thank you.
Thank you.
Thank you so much for your presentation, ma'am. Now I would like to call upon our next presenter for this session. Our next presenter is Avanti Chikore, presenting a paper on the title Internet of Things and Urban Living, Improving Sustainability and Operational Efficiency in Smart Cities. I request you to kindly take over with your presentation, please. Ms. Avanti.
Good morning, everyone. I am Avanti Chokhare from the Faculty of Science and Technology Department, Datta Mege Institute of Higher Education and Research, Savangi. Along with my co-author, Professor Rina Satpute, I am pleased to present our research paper titled Internet of Things and Urban Living, Enhancing Sustainability and Efficiency in Smart Cities. Our paper ID is 3. Thank you for giving me this opportunity. Let me begin my presentation. This slide presents the outline of my presentation. I will briefly discuss introduction, research objectives, IoT layered architecture, applications of IoT, benefits, challenges, advanced IoT architecture, future directions, conclusion, and reference. Now let us begin with the introduction. Rapid urbanization has increased the demand for efficient transportation, healthcare, energy management, and other public services. Traditional urban management system often struggle to meet these growing demands. The Internet of Things or IoTs connect sensors and smart devices to collect and analyze real-time data. This enables faster decision-making, improves operational efficiency, and supports the development of sustainable, citizen-centric smart cities. The objectives of this research are: first, to develop a scalable IoT-based framework for smart city applications. Second, to improve essential urban services such as transportation, healthcare, energy management, and waste management. Third, to integrate technologies like IoT, cloud computing, edge computing, and artificial intelligence for intelligent real-time decision making. Fourth, finally, to prompt sustainable urban development while improving the quality of life of citizens. Now, layered architecture for smart cities. This figure illustrates the layered architecture of an IoT-based smart cities. The perception layer collects real-time data using sensors and IoT devices. The network layer securely transmits data using communication technologies such as Wi-Fi, 5G, Bluetooth, and the Internet. The middleware layer acts as an intermediary between the network layer and the application layer. It manages communication among IoT devices, stores and integrates data, support device management, provide API and service management, and enables intelligent decision making before forwarding the processed information to smart city applications. Finally, the application layer delivers smart services including transportation, healthcare, energy management, environmental monitoring, and public safety. Together, this layer enables intelligent and efficient city operations. IoT has several important applications in smart cities. In transportation, it supports traffic monitoring, smart parking, and route optimization. In energy management, it enables efficient power distribution and energy monitoring. In healthcare, IoT allows remote patient monitoring and faster emergency response. It also improves waste management through automated waste collection and optimized disposal routes. Additionally, IoT continuously monitor air quality, water quality, and population, helping create a healthier urban environment. IoT provides several important benefits. It improves the utilization of resources such as energy and water. It enhances operational efficiency through automated and real-time monitoring. IoT also strengthens public safety by supporting intelligent surveillance and emergency response systems. Furthermore, it promotes environmental sustainability by reducing pollution and optimizing resource management. Overall, IoT significantly improves the quality of life for citizens. Although IoT offers many advantages, it also presents several challenges. Security and privacy are major concern because large amount of sensitive data are exchanged. Interoperability is another challenge since devices from different manufacturers must communicate efficiently. As the number of connected devices increases, scalability becomes essential. Additionally, developing IoT infrastructures requires considerable investments. Finally, proper governance and standardization regulation are necessary to ensure secure and reliable implementation. This slide presents the advanced IoT architecture for smart cities. The process begins with IoT sensor and smart devices connecting real-time data. The data is transmitted through communication network. Edge computing performs real-time processing close to the data source to reduce latency. The processed data is then sent to the cloud for storage and advanced analytics. Artificial intelligence analyzes the data to generate integrated insights. This insight supports various smart city applications such as transportation, healthcare, energy management, and environmental monitoring. The future of smart cities will be driven The future of smart cities will be driven by several emerging technologies. Artificial intelligence will enable predictive analytics and smarter decision making. Edge computing will provide faster data processing with lower latency. Blockchain will enhance data security and transparency. Digital twin will create visual modes of cities for planning and monitoring. Together, these technologies will contribute to greener, smarter, and more sustainable cities. In conclusion, IoT has the potential to transform urban living by creating smarter, safer, and more sustainable cities. Although challenges such as security, privacy, and interoperability remains, continuous advancement in IoT technologies will play a significant role in shaping in the future of smart cities. Thank you. These are the major research paper and publications that formed the foundation of this study. They include research of IoT smart cities, cloud computing, edge computing, and enabling technologies. Thank you for very much for your very valuable time and attention.
Thank you so much. I'll ask our session chairs. Do we have any questions?
Thank you, Avanti. Have you implemented something, or this is just a survey paper kind of thing? Have you worked on any more? Am I audible to you? Hello?
Miss
Hello?
Avanti, is sir audible to you? Hello?
Hello?
Can you
Yes.
hear me, Avanti?
Yes, sir.
Yeah, have you just have you proposed any model, or have you implemented something, or you work on something, or this is just a survey and just survey kind of paper?
Survey kind of paper.
I didn't see any implementation or any model in your presentation. Like you haven't proposed that this is just an introductory kind of thing.
Yes, sir.
Okay, no questions then. Thank you.
Ma'am, do we have any questions from your end? Okay. Seems like there are no further questions. Thank you so much for your presentation, Savanti. I'd like to now call upon our next participant for the session. Our next participant is Joseph Affrier, presenting a paper on the title Machine Learning Based Phishing Detection in Online Learning Environments, a systematic review. I request you to kindly take over with your presentation, please, sir. Sir Joseph. Hello, am I audible? Sir Joseph? We cannot hear you, sir. Hello? Is this mic connected to the system from which you are sharing your slide? Hello? Could you please try presenting once again? Hello? I request Sir Joseph to kindly try to present once again, and please check with the mic if possible. We cannot hear you, sir. Seems like there is some issue with the system for Sir Joseph. I would like to call upon our next presenter meanwhile. So we cannot hear you. Could you please check for the mic in the systems? I request you to kindly rectify on your end. Meanwhile, I'll just take up the next participant, sir. Okay. So I'll just call upon our next participant. Our next participant is Bullet Tiwari, presenting a paper on the title Predicting Trends, Anomalies and Failures in IoT Networks and Devices Using Machine Learning Models. I request you to kindly take over with your presentation, please. So Bullet Tiwari, okay. So you are on mute. I request you to kindly unmute yourself.
I'm audible?
Yes, sir, you're audible.
No. Okay. So, good morning, everyone. My name is Bullet Tiwari, and I am an MCA student at the Kamege Institute of Higher Education and Research, Wardha. Today, I'm going to present my research paper titled Predicting Trends, Anomalies, and Failure in IoT Networks and Devices Using Machine Learning Models. This work was carried out under the guidance of Professor Rina Satpute. So now let's begin with my presentation. This presentation is divided into 7 parts. First, I will introduce the research topic. Then we will discuss about the existing approaches, then problem existing approaches. After that, proposed methodology, resultant discussion, uh, and conclusion and future work. So the Internet of Things is one of the fastest growing technology today. It connects physical devices such as smartwatches, healthcare sensors, industrial, and ATC devices to the internet. And these devices are continuously generated a huge amount of data, and as the number of connected devices increases, managing and monitoring them become more difficult. So that's why we need IoT and machine learning. So machine learning provides a better solution because it learns patterns from historical data. It can predict future trends, uh, detect abnormal behavior, and forecast failure before they actually occur. So in our existing approaches, we can have institutions detection. Machine learning techniques such as support vector machine and deep learning have been applied to detect cyber attacks in IoT networks. After that, anomaly detection in assemble learning, deep learning, and feature reduction methods have improved anomaly detection accuracy while reducing computational complexity. Uh, Next, we have federated learning. Distributed learning enables local model training on edge devices, reducing communication overhead and preserving data privacy. After that, predictive maintenance, machine learning, and digital twins are used to predict equipment failures, reduce downtime, and improve overall operational efficiency. After that, cloud and REST-based architecture help on cloud-supported frameworks, and REST-based IoT integration provide a scalable data processing and communication. So next, the problems we can face in existing approaches is existing research primarily address individual problems. Like at a time, it can focus on like anomaly detection only or etc. But
I'm so
in
sorry to
this,
interrupt, sir. Could you
yes,
please place the mic little closer to you?
okay, okay, yes. Now I'm clearly audible.
Uh, yes, you're
Hello.
audible. And actually, it was little less. The volume was little less. Okay, please continue.
Okay, sorry for inconvenience, ma'am. So the IoT edge devices have limited computational resources and energy constraints. Real-time applications require low latency processing that centralized system cannot always provide. And also the major concern is data privacy and regularity, compliance, and remain significant concerns. Few strategies integrate predictive analytics, anomaly detection, deployment strategies, and regularity consideration into a single architecture. So, in our proposed methodology, this is the in our proposed. Sorry, give me a second. So in our proposed framework, it consists six major stages. First is data acquisition. In this stage, we can collect sensor and operational data from IoT devices. After that, the data pre-processing, it will remove noise, normalize data, and handling missing values. After that, feature engineering, extract meaningful feature and reduce dimensionality. And machine learning model selection can select supervised, unsupervised, or deep learning models based on the application. After that, deployment strategy can deploy models using cloud, edge, or federated learning. And at last, sixth stage, continuous monitoring. We can continuously retrain models to adapt to a changing environment. Then we come to results and discussion. The proposed framework is designed to predict operational trends for proactive system management, detects that can detect anomalies caused by malicious activities, malfunctioning devices, or unexpected behavioral changes, forecast equipment failure to enable predictive maintenance and reduce downtime. To support flexible deployment through centralized, edge-based, and federated learning architecture, and improve reliability by balancing predictive performance, computational efficiency, privacy, and scalability. So, our final phase, in conclusion phase, machine learning enables Internet of Things system to predict trends, identify anomalies, and forecast failure before critical event occur. The proposed framework combines predictive analytics, anomaly detection, and deployment strategies into a unified architecture. It also considers computational resources, privacy, latency, and scalability for reliable IoT operations. And secure and effective machine learning development requires interdisciplinary collaboration and compliance with evolving privacy regulation. So our future works include the paper identifies the following future research direction: development of energy-saving machine learning algorithms, a stronger defense mechanism against malicious attack, a scalable federated learning optimization, lightweight anomaly detection model using fewer features, and simpler AI frameworks for regulatory compliance and governance. Uh, Thank you.
Thank you so much, sir. I would like to ask our session chairs if they have any questions for you.
Um, hello, Blake. Can you hear me?
Yes, sir. Yes, sir.
I'm sorry, your presentation was not properly clear audible. I'm unable to get your voice properly. I still have a few questions for you. Have you just this is again the proposed work, or it is just a survey kind of thing, or you have implemented something on the real IoT data?
First of all, sir, sorry for the inconvenience from my side, and this is only the proposed work. We can.
So nothing has been implemented yet?
Yes, yes, sir. You cannot implement it.
Okay, thank you.
Thank you, sir.
Why you have mentioned, I have a question, why you have mentioned machine learning? Are you
Ma'am, Your voice was breaking. Sorry for interrupting you.
Are you not trying to include deep learning? Is there a
What, ma'am?
particular
Sorry,
reason for?
sorry, ma'am. I can't hear you.
Ma'am is asking, are you not trying to include deep learning?
Yes, currently I am include only machine learning. I can include deep learning too, but not now. It is on my future scope.
Voice is very low. Okay.
Yes, ma'am. Thank you.
Thank you so much for your presentation. Now, I would like to call upon our presenter, Sir Joseph. If you are available with us and the situation with the mic has been corrected, I request you to kindly please take over with your presentation, please. So, Joseph, sir, do we have you here? Okay. Due to some issues with the mic, he's unable to present right now, I guess. So we'll take up I'd like to call upon our next presenter. Our next presenter is Rosalind Olvostinen Ogudokun, presenting a paper on the title Predictive Modeling of Extramarital Affairs Using Socio-Demographic and Relationship Factors, a comparative analysis of KNN, linear regression, and support vector regression. I request you to please kindly take over with your presentation.
All right. Good morning, and good morning, everyone. Let me share my screen.
Yes, ma'am.
Okay. Yeah, I believe you can see my screen now.
Yes, ma'am. Yes, ma'am.
Yeah. All right. Okay. So, once again, good morning, and I'm Rosalind Oluwaseun Ogudokun from the Department of Computer Systems Engineering, Sewanee University of Technology, South Africa. And my topic is on predictive modeling of extramarital affairs using social, demographic, and relationship factor. It's a comparative analysis of KNN, linear regression, and support vector regression. Those are 3 machine learning models. So why does this study actually matter? We know that infidelity in is socially sensitive, and the modeling question is practical. That is, what can be predicted and what cannot be predicted in infidelity. So infidelity can damage trust, it can trigger psychological distress, and can contribute to relationship breakdown. This is it looks like more or less an interesting topic, because we are talking about relationship, whether you are married or you are single. So the power research link infidelity to emotional harm and conflicts, and also separation. And we discovered that recent deep learning studies report stronger classification performance, but interpretability remains a concern. So this paper or this study tests whether simpler model can offer a transparent baseline for counseling or for counseling-oriented analytics. So the contribution here is not just the trying to get high accuracy, but the contribution is actually with trying to get to be careful about the negative results, showing the limits of simple prediction, a complex human behavior. So the research question here is that can interpretable ML models such as KNN, linear regression and SVR reliably predict the extent of extramarital affairs using social, demographic, and relational variables. So we came up with 4 objectives. The first one is we try to engineer meaningful variable from the affair data set that was gotten from a public repository. Then we try to implement the KNN logistic regression and SVR for regression. And also we try to evaluate the performance with accuracy, MSE, and R square. And then we compare the simple model against the broader literature on predictive modeling of infidelity. So the core contribution here is trying to build a transparent benchmark showing that low complexity model are easier to explain, but not necessarily strong enough for the behavioral regression tasks. So the data set that was gotten was a affair data set, which contains 6,366 observations. It has 9 variables, and then we use data split of 70 to 30. That is 70 for training and then 30 for testing. Then the predictors that were used, we used 7 predictors out of the 9 that were present. We had marriage rating, we had age, the years that the couples were married, children, religion, education, occupation, and spouse occupation as well. So the target variable was the affair which shows the amount of time respondents reported spending in extramarital affair. And why do we actually go for regression? The study estimates the extent or duration rather than simply classifying affair versus no affair. So the key data challenge here is that the target is highly skewed towards 0, making exact continuous prediction difficult. So this was the proposed model flow, and we had our data set using the 3 machine learning model, and then we evaluated the models. So the actual experimental flow was this. We had the data set, which is the fair data set, which was preprocessed by checking the missing values, by checking outliers, and then we conducted encoding and scaling using 1/0 encoder, and then standardization. We also did the model training using the 3 machine learning models, and then we evaluated using accuracy, MSE, and also R square, and we conducted interpretation, which is limits and implication. So these were the models, like I said earlier. For the KNN regressor, we try to predict by averaging the target value of the K most similar training cases. And then it shows that it works well only when similar cases are genuinely informative. And then for the linear regression, we conducted a fit on the weighted linear relationship between the predictor and the target. And this was easy to interpret, but it was weak for non-linear behavior. And the last one, which is the SVR, we fit an insensitive regression function using support vector and the kernel. So it was more flexible and it was sensitive to tuning and scale. So at the end of the day, we had our results. This result 1 is showing the accuracy and error. And we have the model accuracy comparison, comparing each of the accuracy of the model. And then we have the model square error comparison as well. And then the KNN predicts more cases within plus or minus 0.5 of the actual value, but all accuracy remains low and the MSC value are close across model, meaning prediction error remains lower. So we also evaluated using the R square by model, that is the variance explained, and it was discovered that the R square value were close to 0, and this indicates that the model explained very little variance in time spent in extramarital affair. So this means that the average, the available variables have some signal, but they were not enough for accurate continuous prediction. And a negative SVR R square indicates the performance was worse than predicting the mean. So this is a valuable negative result showing that the transparency alone does not solve weak signal, skewed outcome, or missing psychological predictor. So why we try to state why these models actually struggle. So the low score are not just a model problem. They actually reflect that the data set, the outcome, and the construct limitation. One is that the limited variable, that is the data set lack personality traits. They also lack relationship satisfaction scale and also communication quality and psychological indicators. So these were not present in the data set that was used for this study, and this actually made the model to struggle while training. And also the skewed target. So most respondents report no affair. So continuous regression faced a highly imbalanced data set, and also the zero heavy outcome was the outcome that was gotten from this skewed data set, skewed target. And then regression difficulty is another reason why the model struggle. That is, they were trying to predicting how much time is harder than predicting whether the affair occur or not. So when we are predicting whether the affair occur or not, which is a classification result, which is a classification experiment, is easier than trying to predict how much time that was used for that affair. Then also human complexity was another reason why those models struggled to perform well. Infidelity is affected by conceptual, emotional, relational factors that are not captured in the 9 basic variables that the data set actually had. So the balanced interpretation here is that deep learning may capture non-linear patterns better, especially for classification, but it often reduces transparency. And this practical challenge is to improve prediction without losing accountability. So in conclusion, transparent models are useful for baseline, but richer data analytical safeguard is essential. So we talk about the issue of the data set not having some variables, which actually led to the models struggling and not performing well. So in conclusion, the question that was raised earlier was answered that simple interpretable model can dictate limited signal, but they cannot rely on prediction to the extent of extramarital affair from the available variable. So when unable to actually predict perfectly with the data set that was available for us to use, we had issues with predicting well with the data set because it did not have the variables that we needed for the interpretability. So the conclusion is that the KNN had the highest accuracy, but the absolute accuracy was still low. And then the linear regression had the lowest MSC and highest R square, but they explain little variance. And then the SVR performed poorly under the chosen configuration and highly sensitive to tuning. Then in the future, we plan to use richer psychological and relationship quality variable. That is, we get a data set that has these psychological and relationship variables, and then we try to evaluate classification. We can evaluate using trying to check whether an affair occurred or not, and then we can also try to get a multi-class data set. Then we can add explainability, fairness analysis, and external validation before the real world use. Thank you.
Thank you
So
so much,
these
ma'am.
are some of the references that were used, and thank you for your attention.
Okay, thank you so much, ma'am. I would like to ask our session chair, Dr. Jain. Sir, do we have any questions?
Thank you, Rosalind, for the presentation. I have few questions for you. Which features you have considered for on the training and training and test data set?
Yeah, for this study we considered I think 7 of them. Let me go back. I mentioned here that
Yeah, I saw in the
here
first
we
slides,
use
initial slide. Yeah, these are the
7 of them. That
predictors.
is marriage
So,
rating, the age,
so
the
which
years.
feature contributed the most?
I don't think that was why I said in future we plan to explain more on the future. We didn't actually look into that.
Okay, so have you considered the false positive data like result as well?
No.
There is a
We
possibility that you can have the false positive results. So have you considered that in your implementation or your models?
no, we didn't for this study. We plan to check that in the future as well. That was what I mentioned. That is why when we are trying to use classification aspect of those models, so we can check whether an affair actually exists or not.
Okay, so the R square value I observe in one of your slide that is close to 0, and like on what basis have you claimed that the KNN is outperforming the other models?
We checked that through the we used that through the result that was gotten. That is here. The KNN had the highest accuracy. I think I made a mistake in this my representation of accuracy. So yeah, but in the report it was stated that the KNN has the highest accuracy in terms of using accuracy to actually evaluate. But the MSC, the value was actually for all the models, they were actually you can see it's actually high, which is not meant to be. So but overall, with the result that was gotten, it was discovered that KNN actually did better than the other models.
Okay, thank you.
Thank you, sir.
Thank you so much, ma'am, for your presentation. Now I would like to call upon the last presenter. If you are available with us, I request you to kindly please take over with your presentation. Sir Joseph, if we have
Yeah.
anybody, yes.
Yes, I'm available, please.
Okay. We'll stop presenting.
Yeah. Thank you for the opportunity granted me. I'm Joseph, presenting on machine learning-based phishing detection in online learning environments, a systematic review. The growing threat. So the COVID-19 pandemic forced educational institutions to adopt online learning, expanding digital spaces that cyber criminals exploited to launch phishing attacks against students, faculty, and institutional systems. Expanded attack surface. Rapid digital expansion created new vulnerabilities across educational platforms. Dynamic threats. Phishing techniques continuously evolve, outpacing static defense systems. High stakes. Student data, institutional records, and financial information are all at risk. Look at the research methodology. The Prisma guided systematic review was used. 40 studies from 2013 to 2023 were selected from IEEE Explore, Springer Link, and Google Scholar using keywords online learning security, phishing detection, cyber threats, remote learning protection. 40 studies reviewed, peer-reviewed publications spanning a decade of research. 3 academic databases, IEEE Explore, Springer Link, and Google Scholar. Comparative analysis, algorithms, datasets, metrics, and framework designs evaluated. Top performing machine learning algorithms have random forest, so up to 99.31% accuracy, uses multiple decision trees to reduce overfitting, gradient boosting, combines weak classifiers into a powerful model, achieved 97% accuracy. Deep learning have using a CNN, LSTM, RNN, superior at detecting malicious URLs, consistently exceeds 90% accuracy. Neural reinforcement learning classify 98.6% of phishing emails with low false positive rate. So these are the key study findings at a glance. The problem based on phishing URL detection, phishing website detection, phishing website detection, phishing web page detection, phishing email detection, and real-time anti-phishing with their key results. Deep learning approaches. Convolutional neural networks extract spatial features from web content and have the long short-term memory, capture sequential URL patterns. Recurrent neural networks outperforms traditional methods in malicious URL classifications. So why the deep learning excels? So deep learning Excel models detect complex non-linear patterns in URLs and web content that traditional classifiers miss. The CNN, LSTM, and RNN architectures achieved over 90% accuracy in most scenarios with strong resilience to adversarial evasion. RNN methods detect malicious URLs with greater accuracy than other approaches, demonstrating substantial deep learning capabilities for phishing detection. 3 core challenges: real-time detection. Phishing tactics evolve faster than static models. Systems require constant monitoring and algorithm update to close attack windows. Dataset compatibility. Detection models must be trained on diverse comprehensive datasets. Incomplete data reduces accuracy across varied institutional environments. Resource constraints. Most online learning platforms lack the infrastructure and budget to deploy and maintain advanced, continuously updated security systems. The human factor. User education as a critical defense layer. Studies by our reference 54 and 30 show that users who understand phishing attacks have a substantially decreased likelihood of becoming victims. Training 48 users improved detection results. We have awareness campaigns, public education programs reduce susceptibility to social engineering, cognitive training, understanding how users process suspicious content improves defense, combined strategy. Machine learning detection plus user training will give us the strongest institutional protection. Limitation and future research directions. Hybrid detection systems. Future work should combine multiple detection methods into unified, comprehensive cybersecurity frameworks. Adaptive real-time mechanisms. Security systems must establish adaptable mechanisms that protect against both current and future threats in real time. Human behavior research. User training needs, behaviors, and organizational culture must be studied to develop better security practices. Conclusion and recommendations. Machine learning and real-time detection systems are essential for safeguarding online learning platforms, but technology alone is not enough. How to deploy machine learning frameworks, use the random forest, gradient boosting, and deep learning for greater than 90% detection accuracy. Enable real-time alerts, implement automatic defenses that respond to emerging threats instantly. Train your users. Combine technical solutions with continuous user education to reduce human error. Updates continuously. Maintain adaptive systems that evolve alongside phishing tactics and threat patterns. Thank you for your audience.
Thank you so much. Request Chair, any questions from your end, sir?
Go to slide number 4, please.
Come again, please.
Can you hear me?
Hello, yeah, I can hear you.
Yeah, slide number 4 from your presentation.
Number 4.
How do you obtain those results? Like the random forest 99.31, gradient boosting is 97, then the other models 90 and 98.6.
So after using the Prisma and the analysis done based on the analysis on algorithms and data sets metrics.
So what features you have considered, what matrices you have considered, what platform you have considered, what data set you have considered for those, like they different researchers have must done this operations on different data sets. So how you are bringing them to a same platform at the same level and you are comparing it, like how do you what parameters you have considered here?
Let me see. I'm trying to get them, but currently it's like
Could you go again,
yeah.
sir? What did you say?
So
Okay.
we're thinking about No. Please, can I be
No
heard?
idea.
Hello.
Okay. Thank you.
Thank you so much, sir, for your presentation. Due to some issues with the network with Dr. Ruchi, ma'am is not able to ask any questions further. So with this, we end our session. Thank you so much, Sir Joseph, for your presentation. Okay. One second. All right. Okay. There were some issues with the presentations. One second. Okay. With this, I would like to end up our session. I sincerely thank all our authors and presenters for their excellent presentations and contribution to this session, and all our participants for being the part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this 10th version and all the previous 9 versions of this conference. We'll be happy to have you in the 11th version in 2027. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months, so kindly cooperate with the team of WorldS4 2026. I also would like to thank our session chair, Dr. Jain, for being a chair to our session. Sir, this is a token of appreciation for our chair on the behalf of Team World S4 2026 and Global Knowledge Research Foundation and partners. Thank you so much for your valuable presence, sir. Before we close this session, would you like to address our presenters with your words?
Yeah, thank you, Prashi. Dear participants and guests, as we conclude this session, I would like to extend my sincere gratitude to all our participants and presenters for your excellent research and contribution, active participation. I would also like to express my appreciation to the conference organizers, sponsors, reviewers, and the volunteers. It has been a privilege to serve as the session chair and witness the exchange of innovative ideas and valuable perspectives throughout this session. I wish you a productive and enjoyable remainder of your conference and continued success in your research and professional endeavors. Thank you. Have a wonderful day. Thank you, Prashi.
Thank you so much, sir. I would like to also display the token of appreciation for Dr. Ruchi Nanda. Ma'am, do we have any last words from your end? If the networks is controlled right now, I think.
Yeah, I am in middle of something, but yes, as we conclude this session, I want to first of all congratulate all the authors for sharing their valuable research and wish them their continued success. And thank you so much, Prashi, for handling the session as per the timings. Thank you, everyone. Thank you, organizers, GR team, for providing us opportunity for acting as session chairs in the conference. Thank you all.
Thank you so much, ma'am. I just request before we close our session to all of you all to please switch on to your cameras so that we can have a quick snapshot of this virtual session we just attended. Requesting all our participants and guests to please switch on to your cameras so that we can have a quick snapshot of our virtual session. Requesting all, please kindly switch on to your cameras. All our presenters, I request you to please switch on to your cameras. Requesting presenters to please switch on to your cameras if possible. All right. Thank you so much for being a part of this session to all of you all. Thank you so much. We'll meet you in the next session in 2027. Thank you so much for your patience and being here. Thank you so much. Thank you.
Thank you.
Thank you, sir. Thank you.